So today we're going to talk about intermolecular forces. And what does inter mean? Between. So these are forces between molecules. Basically, if you have a container or a beaker or something like that, and it's full of different molecules, those molecules are attracted to each other. And those attractions are defined in different ways depending on their strength and depending on what creates them, but regardless, they're attracted to each other. All molecules have some amount of attraction to each other. The first type is called London dispersion forces. And these exist between all molecules. All molecules have London dispersion forces, and these are due to temporary dipoles within molecules. And like I said, this is all molecules have these types of intermolecular forces. Temporary dipoles means they're not permanent like the ones we talked about with the polar molecules yesterday. They're temporary. Electrons are in constant motion, so at any given minute, second, nanosecond, there could be more electrons on one side of the molecule than the other. Just like in our hallway during passing period, at any given second, there could be more students in E than W. Within a molecule, you could have more electrons on one side than the other, temporarily. And it's in those moments that you get those partial positives and partial negatives, and they're attracted to each other. But they're fleeting. Do you know what fleeting means? It comes and goes. So these are not necessarily what we think of as strong intermolecular forces, but they exist. And if the molecules are bigger, they can be stronger. The next type are dipole-dipole forces. These exist between polar molecules. If we look at a polar molecule, like HCl, it has a partial negative side and a partial positive side. If I have a whole entire beaker of HCl molecules, the positive side of one will be attracted to the negative side of another, because opposite charges attract. So the positive side of this HCl molecule kind of sticks to the negative side of this HCl molecule. That is a dipole-dipole interaction. It's a dipole-dipole force. And the last type is hydrogen bonding. Sounds like a bond, but it's not. It's an intermolecular force. And hydrogen bonding is a special type of dipole-dipole. Where H is bonded to, it's HN, H to O, or H to F. This is what gives water all of those special properties. some of the special properties. So we have in water, we have a negative side and a positive side. In a beaker of water, the positive side is attracted very strongly to the negative side of another. And we'll talk more in AP about why that is, but these are a special type of dipole-dipole that are stronger. And that's because of hydrogen and its properties, basically. And NO and F and their special amount of electronegativity. These are the most electronegative atoms. It's those two combined that makes hydrogen bonding so strong and special. Questions? So if we're going to rank these are the weakest, these are medium, and these are the strongest. But we're going to find out later that, yes, these are weak and medium and strong, but other factors come into play. Like things that are very large have stronger intermolecular forces than things that are very small. We'll talk about that later. Any other comments or questions?